The first time an American soldier tried to pour fuel from a captured German can, he didn't spill a single drop. And that small, almost invisible moment planted a quiet question in his mind that would later echo far beyond that muddy roadside. He had expected the usual struggle, fuel sloshing over the rim, hands slick with gasoline, the sharp smell burning his nose while someone shouted for him to hurry. Instead, the fuel flowed cleanly and smoothly, as if the container itself understood the urgency of war. In a conflict defined by noise, chaos, and speed, this strange little object worked with calm precision. No one gathered around to admire it. No officer wrote a report about it that day, but the seed had been planted, and once planted, it refused to die. Fuel was the bloodstream of the modern battlefield. Without it, tanks became steel coffins, trucks turned into useless scrap, and aircraft were reduced to expensive decorations on improvised runways. The United States Army knew this better than anyone. Its entire strategy depended on movement, supply lines, and relentless logistics. American factories could build almost anything in staggering numbers, and commanders trusted that production would solve every problem eventually. If something broke, they made more of it. If something failed, they redesigned it fast and moved on. In that mindset, a fuel container seemed trivial. It only needed to hold gasoline and survive transport. Anything beyond that was unnecessary refinement. Before encountering the German design, American fuel cans were awkward, fragile things. They required funnels that were easily lost, lids that leaked under pressure, and shapes that didn't stack well in trucks or ships. Soldiers cursed them daily. But curses rarely reached the ears of engineers. War moved too fast, and complaints drowned in paperwork. When American units overran German supply dumps in North Africa and later in Europe, they found something different. Neatly stacked metal cans sat ready for use, identical in shape, solid in feel, and strangely elegant despite their brutal purpose. The Germans called them Wehrmacht canister, but Allied troops quickly gave them a simpler name, jerry cans. At first glance, they seemed ordinary, rectangular, made of steel, painted dull colors. But once soldiers used them, the differences became obvious. The lid opened without tools. The fuel poured smoothly even under stress. The can didn't collapse when dropped. It didn't leak when exposed to heat. It could be carried by one man running, two men walking, or passed quickly down a line of exhausted hands. These weren't luxuries. They were solutions to problems soldiers faced every single day. The German designers had not guessed what might be useful. They had studied how fuel was actually handled in war and built the can around those realities. American officers noticed the efficiency almost immediately. Reports filtered upward, noting that German cans were superior to Allied versions. The conclusion was simple and confident: copy it. The United States had copied weapons before, borrowed ideas, improved them, and flooded the battlefield with better versions. There was no shame in imitation if it led to victory. Engineers were given examples of captured cans and instructed to reproduce them as quickly as possible. Speed mattered more than subtlety. Factories were already stretched thin, and any delay risked slowing the advance. The goal was not perfection. The goal was adequacy. The American copy looked nearly identical at first glance. Same general shape, same capacity, same rough dimensions. On paper, it checked every box. Production began rapidly, and thousands of cans rolled off assembly lines. Commanders felt reassured. The problem, as far as they were concerned, had been solved. Yet as these cans reached the front lines, soldiers began to notice small frustrations. The lid sometimes required extra force. The fuel flow wasn't as smooth. The metal felt thinner, more prone to denting when dropped, or stacked under heavy loads. None of these flaws were catastrophic. But war was not a collection of catastrophes alone. It was also a long accumulation of small failures. One dent meant a can that no longer stacked properly. One leak meant fuel wasted, time lost, and tempers flaring under enemy fire. A poorly designed handle meant slower movement when seconds mattered. American soldiers adapted as they always did. They cursed, improvised, and kept moving, but many of them quietly preferred captured German cans whenever they could get their hands on them. It was an unspoken vote of confidence cast by men who trusted their lives to equipment every day. They didn't care who designed it. They cared that it worked. Back in the United States, engineers believed they had successfully replicated the enemy design. They had matched the dimensions and materials closely enough to satisfy procurement requirements. What they hadn't matched was the philosophy behind the object. The German can was not just a container. It was the result of obsessive attention to use cases, stress points, and human behavior under pressure. Every curve, seam, and handle had a reason. The American version was a visual copy, not a conceptual one. It assumed that if it looked the same, it would perform the same. Reality disagreed. As the war dragged on, logistics officers began to notice patterns. Replacement rates for American cans were higher. Reports of leaks and damage were more frequent. Fuel losses added up, not dramatically but steadily. Each lost gallon meant another truckload had to be delivered, another convoy exposed to ambush, another delay in operation. None of this was enough to change the course of the war on its own, but together, these inefficiencies formed a quiet drag on momentum. The irony was painful. America, the industrial giant, had stumbled over something the Germans had perfected before the first shot was fired. Soldiers, meanwhile, developed their own preferences and rituals. They marked good cans, hid them when possible, and guarded them jealously. A reliable fuel container became a prized tool, not because it was glamorous, but because it reduced friction in an already brutal environment. Veterans would later recall that some of the best equipment they used during the war came from enemy stockpiles. The jerrycan became a symbol of that uncomfortable truth. It was proof that innovation did not belong to one nation alone. Part one of this story is not about failure in the dramatic sense. It is about assumption. America assumed that scale could compensate for subtlety, that copying shape was enough, and that small details didn't matter when factories could produce millions of units. The battlefield quietly disagreed. In mud, heat, and chaos, details became everything, and though few realized it, at the time, the humble fuel-can had already taught a lesson that would echo long after the war ended. Real genius often hides in the smallest decisions, waiting to be noticed by those forced to rely on them under pressure. What separated the German can from its American imitation was not some secret metal alloy, advanced machinery, but a mindset that treated small inconveniences as unacceptable failures. German engineers had watched soldiers struggle, spill, drop, curse, and improvise long before the war erupted across Europe. They understood that fuel handling happened in darkness, rain, freezing cold, and under fire. It happened when hands were numb, gloves were soaked, and nerves were shut. Every design choice had to assume exhaustion, fear, and urgency. This philosophy shaped details so subtle that they were easy to miss, especially by those rushing to replicate the design under wartime pressure. The three-handle system was the most visible example. To an American engineer working from blueprints, it might have looked excessive, even wasteful. One handle was enough to carry a container after all. Two might help with balance. But three, the German designers had thought beyond individual carrying. One man could grab the center handle and run. Two men could each take an outer handle and move heavy loads efficiently. Most importantly, long lines of soldiers could pass cans hand to hand without stopping, each man grabbing a handle instinctively and moving it along in a smooth rhythm. This turned fuel transfer into a near-mechanical process, saving precious seconds and conserving energy. The American copy kept the general shape, but altered proportions slightly, making the grip less natural and the handoff less fluid. The sides of the German can told another quiet story. Those recessed, X-shaped indentations were not decorative. They strengthened the structure, allowing the metal to flex rather than crumple under pressure. When exposed to heat, the fuel inside expanded, and the can accommodated it without bursting seams when dropped from a truck or stacked under weight. The sides absorbed impact instead of collapsing. American versions, made with thinner steel and less precise stamping, lacked this resilience. They dented more easily, and once dented they were never quite right again. A dented can become harder to stack, more likely to leak, and eventually useless. One flaw created a chain of problems that rippled outward. Then there was the lid. German engineers designed it to open without tools. Even when clogged with dirt or frozen by cold, the camlock mechanism provided a tight seal while remaining easy to operate under stress. It eliminated the need for a separate funnel by controlling fuel flow directly from the can. This meant one less piece of equipment to lose, break, or forget. American designers initially underestimated this detail. Their lids sealed adequately in ideal conditions but struggled in the field. Soldiers found themselves prying them open, using knives or improvised tools, wasting time and risking injury. Funnels went missing. Fuel spilled. Again, none of this seemed disastrous in isolation. Together, it slowed everything. Another overlooked detail was the internal coating. German cans were treated to resist corrosion from fuel and moisture. This extended their lifespan and kept contaminants out of engines. American cans, produced quickly and cheaply, often skipped or simplified this step. Over time, rust formed inside, flaking into fuel systems and causing engine trouble. Mechanics cursed the containers without always knowing the source of the problem. Trucks broke down. Repairs took time. The cost was measured not just in money but in momentum. Even the seam placement mattered. German cans used a recessed seam that reduced wear and protected the weld from damage. American versions placed seams in more vulnerable positions, making them prone to cracking after repeated use. These were the kinds of details that never appeared in promotional material or official reports. They were discovered only through repeated failure in real conditions. The Germans had tested for those conditions before the war. America was testing them during it. As reports accumulated, some American engineers began to realize that something fundamental had been missed. They requested original German cans for closer study, not just measurement. They wanted to understand why it worked so well, not just how it looked. This shift marked a subtle change in attitude. Copying was no longer enough. Understanding became the goal, but wartime bureaucracy moved slowly, and factories were already tooled for existing designs. Changes meant delays, and delays meant resistance. Meanwhile, soldiers continued to vote with their hands. Captured jerry cans were repainted, relabeled, and absorbed into Allied supply lines whenever possible. No one asked many questions. If it worked, it stayed. Quartermasters learned to recognize them instantly and often set them aside. The enemy's design quietly became a trusted ally. This was not admiration for Germany, it was respect for competence. The irony deepened as American industry, famous for innovation, struggled to admit that a simple object had beaten them at their own game. The lesson was uncomfortable. Mass production could magnify mistakes just as easily as it magnified success. A flawed design, multiplied by millions, became a massive inefficiency. The Germans, with far fewer resources, had extracted maximum value from careful planning and ruthless iteration before the war began. Their can was not perfect by accident. It was perfect because they had refused to accept good enough. By the time American leadership seriously considered redesigns, the war's outcome was no longer in doubt. The urgency that once drove rapid copying had shifted toward refinement and post-war planning. Engineers documented what went wrong, noting the overlooked genius of the original. These notes would influence future designs, not just for military use, but for civilian applications as well. The jerry can had revealed a universal truth about engineering, usability, and extreme condition. Exposes flaws that peaceful testing never will. Part 2 of this story lives in those overlooked details, in the gap between imitation and understanding. America did not fail because it lacked skill or resources. It failed because it underestimated the value of obsessive design thinking. The German can was a reminder that simplicity is often the result of complexity resolved, not ignored. And though the war raged on with far greater machines and weapons, this humble container continued to teach its quiet lesson to anyone willing to look closely enough. By the time the war neared its end, the story of the fuel can had quietly completed its arc. though few people recognized it as a story at all. It never appeared in victory speeches or newspaper headlines. There were no medals awarded for containers that did not leak. Yet behind the scenes in workshops, depots, and engineering offices, the lesson had finally settled in. The problem had never been that America lacked intelligence or capability. The problem was impatience, the belief that speed and scale could replace deep understanding. That belief had worked often enough to become habit. And habits are hardest to question when they are usually successful. As Allied forces pushed deeper into Europe, supply chains grew longer and more complex. Every inefficiency multiplied itself across thousands of miles. Trucks burned fuel to deliver fuel. Ships crossed oceans carrying containers that would be used, dented, discarded, and replaced again and again. Quartermasters noticed patterns they could no longer ignore. German cans, even those captured early in the war, were still in circulation. American cans required frequent replacement. The numbers told a clear story. Even if pride resisted the conclusion, durability saved resources. Reliability saved time. And time, in war, was often the difference between progress and disaster. Gradually, redesigns were approved. Not loudly, not ceremoniously, but through quiet technical memos and incremental changes. Steel thickness increased. Handle geometry was adjusted. Lid mechanisms were refined. Internal coatings improved. Each fix brought the American can closer to the original it had once assumed it had already matched. Engineers who worked on these revisions later admitted that the German design had forced them to rethink how they evaluated simple equipment. There was no such thing as simple when lives depended on it. What made this realization especially powerful was how transferable it was. The lesson of the jerrycan began to influence other areas of military design. Tools were evaluated not just for function, but for how they were used by tired hands in bad weather. Equipment was tested under abuse rather than ideal conditions. Feedback from soldiers gained more weight. The idea that form must follow real-world function, not theoretical requirements, gained ground. In that sense, the fuel can achieve a quiet victory of its own, reshaping thinking far beyond its original purpose. After the war, the world did what it always does with good ideas: it kept them. The jerrycan design spread into civilian life, humanitarian aid, exploration, and disaster relief. It appeared in deserts, jungles, and frozen wastelands, far removed from its military origins. People who had never heard of the Wehrmacht or Allied logistics relied on it without question. They trusted it because it worked. The design transcended politics, ideology, and history. It became a standard not because it was German or American, but because it respected reality. In the United States, the post-war industrial boom absorbed the lesson in its own way. Engineers taught younger designers about the importance of user-centered thinking, often using wartime examples stripped of national labels. The story of the fuel can became less about who copied whom and more about why details mattered. It served as a warning against arrogance and a reminder that innovation did not always mean inventing something new. Sometimes it meant recognizing excellence where it already existed. For soldiers who had lived through the war, the memory remained personal. Veterans recalled the frustration of faulty equipment and the relief of tools that simply did their job. Many of them remembered the jerrycan not as a symbol of the enemy, but as a reliable companion that never demanded attention. It did not jam. It did not surprise them. It just worked day after day until the war ended and they no longer needed it. That kind of reliability left an impression deeper than any slogan. The greatest irony of all was that America eventually mastered what it had first misunderstood. Once the philosophy behind the design was embraced, American manufacturing could match and even exceed the original in certain respects. But the original lesson remained intact. Perfection is not accidental. It is deliberate, patient, and deeply informed by real use. The Germans had learned that lesson before the war. America learned it during the war. The world benefited from it after. In the end, the story does not belong to a nation or an army. It belongs to the idea that small things can carry enormous weight. A fuel can does not fire bullets or fly missions. It does not inspire fear or awe. Yet without it, none of those things happen. By missing the genius hidden in its details, America briefly underestimated the power of thoughtful design. By finally understanding it, America reaffirmed a truth that still applies today. The difference between good and great is rarely obvious at first glance. It reveals itself only when conditions are harsh, margins are thin, and failure is not an option. And when that truth is learned, it lasts far longer than any war. Even decades later, that truth continues to echo in places far removed from battlefields. Modern designers, logisticians, and engineers still reference wartime examples when debating efficiency versus elegance, speed versus understanding. The fuel can often appear in these conversations not as a relic, but as a benchmark. It represents a moment when necessity stripped design down to its essence and forced creators to confront reality without excuses. There was no room for aesthetics alone, no tolerance for assumptions, and no forgiveness for shortcuts. Everything had to justify its existence through performance. In training manuals and design classrooms, instructors sometimes pose a simple question: why does this object still exist in almost the same form nearly a century later? Answer is never about nostalgia. It is about balance. The jerrycan achieved a rare equilibrium between strength, usability, and manufacturability. Alter one element too much and the system begins to fail. Make it lighter and it dents. Make it cheaper and it leaks. Make it more complex and it slows the user. That balance is difficult to achieve and even harder to recognize once achieved. America's initial mistake was not incompetence, but blindness to that balance. There is also a human lesson buried beneath the steel and seams. In wartime, respect is often reserved for firepower, speed, and spectacle. Quiet competence rarely earns admiration, yet it is quiet competence that sustains everything else. The fuel-can did not win battles directly, but it enabled those who did. It supported movement, endurance, and momentum. By the time this was fully understood, the war was ending, but the insight endured. It influenced how future conflicts were supplied and how peacetime industries approached problem-solving. Perhaps the most remarkable outcome is how invisible the success became. Today, people use similar cans without thinking about them at all. That invisibility is the highest compliment design can receive. When something works so well that it disappears into routine, it has achieved its purpose completely. No instructions are needed. No explanations are required. The object teaches the user through experience alone. So the story closes not with embarrassment or triumph, but with clarity. America copied the jerry can, missed the genius hidden inside it, then learned why that genius mattered. The process was inefficient, humbling, and quietly transformative. In recognizing that perfection had already been achieved elsewhere, America did not lose stature. It gained wisdom, and that wisdom, forged not in glory but in spilled fuel and dented steel, proved far more durable than any single victory.